from the development team at Pronexus. This presentation is about how we can port a VBVoice application, and in particular a .NET VBVoice application, from a desktop application, the normal way we start an application, like our examples that ship with VBVoice, into a service. So this was one of the requirement that people would like to run a VBVoice application as a service for the benefit of running at startup or running on servers that unattended servers where you don't need or nobody is going to log into that server. Running an IVR at the back end is a pretty useful and common practice. However, many people would start their application as a desktop application, and down the road they would like to port it to run as a service, but they still want to be able to run it as a standalone for many obvious reasons, like easy debugging. So here I'm saying that this is not the only way. If you want to debug a service, you can always attach your Visual Studio to the service, but sometimes you want to debug some part of the code, like at initialization. It's pretty hard because when you attach, you have to attach to a process that is already running and already started, so it will be a bit too late for debugging initialization code. And this is where it comes handy to run a debugger from the beginning, right from the beginning in a desktop application. Another thing is that services don't have a GUI, so if you are more familiar with debugging UI, when you debug or when you go step by step, you want to see things happening on the form, then you would rather debug a desktop application rather than debugging the service. So for all that, those reasons, it's a good practice to have your application running in both modes. Like you can start it as a service or a standalone. The way I'm going to explain this one is through one of our examples. Our popular EasyFlow IVR application that ships with VBVoice. I'm going to turn it into a web service. Let me start first a Visual Studio. As we normally do, we always start as administrator, and open the project EasyFlow. This is the EasyFlow, the C# version of the EasyFlow. Everything that I'm going to explain is in C#, but the exact same concept applies to VB language. The EasyFlow project that I opened, I did open it before, so any porting process to upgrade from our shipped examples, which are compatible with Visual Studio 2005. I did these porting settings earlier. So just a quick reminder is to target a 32-bit machine with this setting. Pick a framework. You can use the framework too, but here I'm using the latest framework 4.5. Also added a reference to VBVoice support libs. It gives me more objects that I can work with. It's also pay attention to these references if they are pointing to the same excuse me, to the same directory they exist in, and you need also to verify their properties that do not use copy local, do not use a specific version. So this is the project that I'm going to start with. Let me give you some hints how this works. This application starts, loads, and when you load it, you have to go manually and start by clicking a button. So for a service, when the service starts, you don't have a UI as I said before, so you will not be able to start the service as simple as that because you cannot click any button. So in order to do that, I'm going to make it a simple process that I will add a timer, and so I'm going to add here a timer component. So this timer, it is going to run for 5 seconds, just to make it simple. And after 5 seconds from the beginning, after loading, the tick timer will kick in, and at this point I'm going to call VBV frame one start system. There's don't care about the showing the logs, and that's about it. After that, I don't need that timer anymore. So let me set it, disable it, so it will not run anymore after that. That piece of code works both if you're running as a standalone or if you're running as a service, obviously. The other thing that I'm going to do is I want to distinguish between running as a service and running as a standalone. The code is going to be a bit different, and in order to distinguish between the two, I'm going to use a command line for this. And if you look at how this is all started when you start the application, it actually starts always by this static method called main. So at this point, this code, when we had these examples, this method was made a member of the form. In a more complicated or more complete application, you probably could have it somewhere else because you would have multiple forms or more classes. So you can have it in any class. For making this clearer, I'm going to move this code and put it inside another class, which is just for this purpose. So I'm going to go here and add a new class. Let's call it program. In this class, I'm going to cut this code from here and paste it here. So that is the code to run. Application requires the system component model, and I believe so. Windows Forms. Okay, so we need Windows Forms. Okay, so this way we have it separate just for clarity. It's going to depend on the arguments, so I'm going to add the arguments to this. This is the way to pass it from the command line when it is called. The most obvious way or the simplest way that you would like to use it is that when you double click on the application, you want to run it as a standalone. You don't want to run it any other way. So to do that, I'm going to check if if no arguments are there at all. So we'll start it like this. Else, I'm going to look at the first argument, and if it is using any case, change it to lowercase, and I'm going to use for this one, let's call it, if you want to run it as a service, so let's use the word service. So here I'm going to run as a service. So basically I'm going to call the code that's going to run it as a service in this case. If there's no arguments, then it will run as a standalone like this. So in order to run this this service, first I'm going to show how we can add the service. So basically what you have here in this application is just a form, and we need first to have a service component. That component is going to register with the service controller of Windows. Then Windows, we have to teach Windows how we can interact with the service, how we start it, how we stop it, and all this code need to be added in this application. The code is going to depend on a DLL. So I'm going to create a reference to this DLL. DLL is System Service Process. Here we have it. I'm going to first start by adding this service. So for that, and again, it's much nicer if we have it in a separate class. So I'm going to call it EasyFlow Service. This is the EasyFlow service. It's going to depend, is going to need a reference to the service process. And here I'm going to make it a public class, and it inherits from service base. The first thing that we're going to do with this service is when we instantiate a new service, I'm going to give it a name. All services should have a service name, so it should have a unique name. So I'm going to give it that same name I used. So this when you instantiate it, need to give it a name. Now this name you're going to notice later on during the development of this application that I'm going to use it in several places. So that unique name is every time you need it, every time you want to register the service, to install it, to start it, to stop it, etc. So that name is going to be used several times, and the best way to do that, I would say that we can create a public constant here that is accessed anytime we need it throughout this project. Gonna call it my service name, and we'll put this name here. Now I can use that constant every time I need to refer to the name. So this is the service I created so far. It's not complicated, very straightforward. Now, the purpose of this service, as I said, is that to interact with the application, to start it, stop it, etc. So it's good to show how we can start it. This base class gives us a couple of methods that we can override in order to implement the way to start the service. So the code to start the service, I'm going to put it in a method that here we're going to override, which is on start. Another method of interest is going to be on stop. So let's give a look at the way we started as standalone, just as for reference. What happens here is that when we start in the application, the first thread that is created for the code to execute in this application is going to start at the main, and main will come to this point, and here we are instantiating a form. Now that thread after that, if it exits, if it goes away, the form will be unloaded and the application will be closed. So what you need to do is that you need a message loop, it's called in Windows, that going to dispatch the events that come from the user, mouse clicking, keyboard entries, etc., and dispatch these messages into the object here, which is the form, and stay in that message loop. So keep looping until until we have a special kind of message, which is closing the window, for example, or exiting the application. At that point, we can exit the loop and exit. This whole mechanism is provided by calling application run. So application run, basically you provide here a form and you say, I am interested to dispatch messages to this form, and please stay there until I tell you otherwise. Obviously, if you have multiple, you could have multiple forms, but in our example is one form only. That same mechanism is needed for the service. So when I have the service, when I decide to stop the service, in case you're stopping a standalone application, you go and close it. So it's basically the form itself decide to close itself because you sent a message to the form by clicking on the little X box. In a service, you don't have a GUI, so the only way to stop is to stop the service in the service manager. Look at here at Windows Service services when you have a service, and you can go to that service and click the stop button. So stop here. So when you do this stop, it's going to call this method, and you should have a code here to close. So what I'm going to do here in this example, that I'm going to call that same application object. So here I'm going to need a reference to Windows Forms, and the application class has a method called exit. So when you do exit, it's going to go to all your forms, whatever forms you have, not even forms, even if you have message loop for some other events that are not around the form, and they are going to exit all these message loops and release all the threads. So remember that thread that is running here, the main thread that is running here, that is not the thread that this call is going to be. Again, here I'm trying to mix between the two, explaining about standalone and the service, but I'm going to replace this code for a service later. So this is the exit. Now, how do I start that service? When we start a service by pressing this button, start, the system sends or calls this method that we have to implement here. And that method is being called on a certain thread that we cannot actually keep it. It has to exit. Otherwise, it will keep waiting for the service to start, and will not consider the service started and forever, and eventually it will time out and give an error. That thread is very important to this thread, to the service manager, so it has to exit. So what we need for that, we need another thread to run the form on. So we need another thread, attach call a message loop on that thread and provide the form to do that. So in order to do that, I'm going to create a new thread. So creating a new thread, I need the threading namespace, and I'm going to create that thread in an easy way, straightforward way. So it's a new thread, and here I have to define what that thread is going to do. What's the method that is going to be executed when that thread starts. A more straightforward way is that I would define a delegate, and here I can directly put the code. Let me put it this way. So I can directly put a code to show the code that is going to execute on that thread. That code is a very simple code. It's a form instantiation of the EasyFlow form. So FRM EasyFlow, and then I call run on this form. So that's all what I need to do. What do we have here? Oh yeah, we need to instantiate a new instance, sorry. So this is the code that is needed to run on that thread. So that's pretty similar to this code here that we have. The only difference that this was running on the main thread. Here we have to run it on another thread because that thread that we're running on has to exit. The other difference here you notice here is a new instance was created and passed to the run, and here we're doing it on 2 lines. Did the thread start? No, it did not. So we have to start it, and that's what we do after we create the thread, is that we go and start it. Now by default, threads that are created this way are using the apartment model, the multi-threaded apartment model. This is not good for the way our controls are done. They depend on back end that requires single-threaded apartment model, and that single-threaded apartment model STA is actually defined in that original thread that we ran on. So for our new thread, we need to define it. And in order to define it, we have to tell this thread that, like this, the 2 ways of doing it. Either you tell the thread before, when it is created and before it starts, what apartment model is going to use, or the method that serves the thread, the method that has the code of the thread, could be tagged by this attribute. So at this point, I can do that before starting the thread, is that I define it as using single-threaded apartment model. Now this code is great, with only one problem, is that the code, when you start, will still not get to the start. It's still, this is the first entry point, and when it comes to here with the switch service, this code that's going to start. So I need to add here code to start the service, and in order to do that, I need to create that service at this point and run it. So this is done through the same service process namespace. So what I'm going to do here is I'm going to create a service. This is normally could be starting several services at the same time. So this is the way it is done, is that you create an array of services, and you pass the services. You create an array of these services, and you pass this array to service base run. So that's the way that the service base is going to hold this service as running and call start on each service, and eventually the start is going to end at on start, and on start is going to load the form, and etc. There's still another problem here, is that this thread that we're running here is going to exit, But this thread here is the one that's going to stay running in the process. And we did this one, we made this thread single-threaded apartment model. This thread that we have here, a single-threaded apartment model, we don't need it to be STA anymore. That could go back and to the default MTA, multi-threaded apartment model. But doing this is going to prevent a standalone application from running properly. So I need to do here the same mechanism that I have here. So simply I can go and copy that code here for simplicity. And that should do the trick. The only thing is that I need here to use the threading namespace. So again, the thread that we're going to instantiate the form on is STA. Anything else is MTA. So far we did two things: starting the service, stopping the service, and we did starting basically the service from here. When you click start in the service controller, or you stop it from here. It's useful to some people would like to start the service from a command line for many reasons, like if you have an installer application that install your service and then start it. So you would install the service and then call a command line on that service and start it. Makes sense to do that. So in order to do that, I'm going to use a switch for this one called start. And same thing to stop, another switch. And here, where I'm going to call this start the service to. In order to start the service, that is provided through a service controller. So I need to instantiate service controller. Let's call it a starter. And the service controller is need basically a name for the service. We need that unique name. So this is where I provide it as a constant. So in order to use it everywhere in this application. And on this starter, I'm going to call start. That's about it. I don't need to do anything anymore. So you call this one, and this is going to start the service controller. The service controller will do its magic and then call the start, and the start is going to eventually call our implementation of the onStart. OnStart will start a thread and do this, load the form and etc., and will exit. And the code, when code comes back here, is going to basically exit. And if you're doing that from a command line, it will not block the command line. So and your application is running. The same thing we can do on stop. So let's call it a stopper. new service controller, and it's using the EasyFlow service name, and the stopper is going to stop. Pretty simple code. Now this service requires installation. There is an installation process that is needed. If you look quickly at Windows Registry, we see the list of services are registered in the registry, and this is basically one example. Our runtime manager is registered here, and this is the way to start it. This is a long path to where the service exists, and this is where we started. So we need to basically do things like that, and these things are done through an installer, service installer. In order to do a service installer, I'm going to put that installation code in another class. So let's create a new class. Again, I'm going to call it EasyFlow Service Installer. A bit long name, but give me more idea what it does. I'm going to make this one public in order to let other components be able to start this installer, especially outside installers. And this is going to inherit from an installer object. The installer object needs a namespace, which is configuration configuration install. And configuration install is in a DLL that I need to add a reference to, which is system configuration install. Now I can inherit from installer. The installer needs two things to do. It needs a service process install and an installer for the service itself. So I need to instantiate to have two members, service process, and again I need the service process namespace. So service process installer, and I'm going to call it EasyFlow process installer. And the other component is service installer, and it is EasyFlow installer. Or let's call it EasyFlow service installer. I see here names are the bigger installer is called EasyFlow service installer, and a member is called the same, but that's okay. In the constructor of this class, I need to instantiate these components. So EasyFlow process installer new. The process installer is where you define what account this service is going to run, or this process is going to run. The machine that you're going to install on and you run as a service, we said that we don't want that service, like most of the cases, you don't want that service to be attended, and that machine is a server machine. You don't need to log into that machine. So you would probably run as a system, like any other service. If you quickly have a look at, let's have Runtime Manager, for example. So you see here the service is running as a local system. So you would probably like to run as local system because you'll have access to the whole machine if you want, and at the same time you don't need credentials. You only need it when you install the service. So in order to specify running that the account you want is the system, this is how you set it in the account component. It's useful to mention here that there's no user and there's no password. Obviously there is a password for the administrator, so when you install this service you will either be running as administrator or you will be asked to elevate yourself to an administrator, or it will ask you to accept what you're doing here, and this code will run. The other component that I'm going to here initialize is the EasyFlow Service Installer. EasyFlow Service Installer has the service name, so it actually identifies the service. So I'm going to pass the same name that we have it, and you need a more like a display name. If you notice here, the service, for example, Runtime Manager is called Runtime Manager, while the EXE is VBVRTM, so it's not the same name. Some of these the EXE name is one thing, the service name is one thing, and the display name is another thing. Let's give another example, which might be here we go. So this service name is a short WSCSVC, but the display name is more than that. Is a descriptive name, and this is the name that you see in this column. This is where you refer to it as a user. So we're going to give it a friendly name like that. Well, a bit more friendly than the other one. We'll put a space between EasyFlow and service. And another thing that you can define at this point is how do you want to start this service. So again, this is something you see here. Start, automatic, delay, after delay, or manual, or etc. In a real life application, you will actually run it as automatic. In many cases, you might need to run it as manual. If you are still in testing phase, you want to start and stop manually, start, stop, etc. You don't want it to start when you reboot. So you will set it as manual. In my example, I'm going to set it as manual, and this is something that you can change when you make the final build, for example, before deploying. The last thing here that makes sense to mention is the dependency. That is especially important for services that start automatically. So when you start a service automatically, and especially a VBVoice application, If it is going to start taking calls, then it needs other services like Dialogic, for example. So you actually need Dialogic be running in order to have which one? Yeah, this Dialogic service. So this service is called Dialogic. So it's good if you put dependency on, if you add dependency of your service on Dialogic. Why? Because Windows services have no order. So basically the system pick the order and they start them. And in many cases, if you start first, if your service start first and Dialogic didn't start yet, it will fail, and then it will stop and it will not start properly. If you tell the system that, hey, I depend on this service, I need it to be running. So the system is going to put them in a better order. It will start Dialogic first, then will start your application. So that may slow down a bit the starting process. Let's not call it slow down. It's actually going to delay the start until Dialogic is started. The way I put it, I use it is that I have to use this name. So I'm going to copy this name and put it here. You need for that to pass an array of strings of all the services that you depend on. Another useful thing is you depend on you put dependency on runtime manager. So because again, if you start your service and you need VBVoice licenses, they are not there yet, so you would probably prefer that runtime manager be started first. And the runtime manager name is here, so I'm going to copy it and add it as another string. So now that I have instantiated and initialized the members of those two components, so I'm going to put them, to add them to the installers. So they are like an array of, new installer. Okay. So I need an array of installers, and those two installers are EasyFlow Process Installer and EasyFlow Service Installer. That is all what I need. So at this point, I have an installer. I have some classes here that knows how to install this service. I have the service. It knows how to start and how to stop. And I have the form. It knows how to start system by itself. Well, delay. Remember the delay at the timer at the beginning. I have the command lines here that do the different scenarios, starting as a service, starting and stopping, and etc. I'm going to build have an error, so let's check that. Yep, I did not close this class. So now it succeeds. Let me try to so let's switch here to the example. It is in our examples in C# EasyFlow and it is the debug. Doesn't matter, you can work with the debug or with the release. So here what I'm going to do is that I'm going to register this service. And registering this service or installing this service, which basically creating the registry entry that is required to teach how to start the service, is by calling the install utility that comes with the .NET framework. And that exists with your system on Windows directory, and in the directory of your framework that you're using, and install util, and then you pass the name of the assembly. Let's check what we have here. When it ran, it has assemblies process file located here. This file actually has logs about the installation process. Installing the assembly, disassembly, and no public installers with the run installer attribute. Yes, attribute could be found. So it actually, the installer normally looks for this kind of attribute in order to figure out which class is going to call to install the service. That attribute means that I need to label this class. So I need to put this class and call it run installer. Run installer is a part in a namespace called Microsoft Win32. So run sorry, not in Win32, in the system component model. So run installer, and I have to pass here true to tell that this installer needs to be this is the installer that we need to run. Now let's go back here and run this again. So again here, installing services, service has been successfully installed. Creating log, etc. The install phase completed successfully, and the commit phase is beginning. There's a commit, transactional process. If one of the steps fails, the installers normally roll back. So and commit phase completed. So I'm guessing that if we switch here, refresh this window, we're going to see that our service is installed. That's great. Let's look again here. We refresh this the registry, and services easy flow, and we see easy flow service is installed here, and it has that's a long one. Let me try to start it. Can I start it? That's taking too long. So what's wrong here? If we have a look here at Task Manager, and this is running, remember, as a service is running at the system user in session 0, so you need to have access to all instances. You have to start it again because it timed out. So here you see that there is a service that is trying to start but does not start. If we look at the properties of this service and we see how does it start, it's starting in this location, the exe name is here, etc. But it does not start. So there is something here missing. You see this path to executable? This is how the service is being called. So that path is exactly how the service is being called. While we defined here that the service, when the service is going to start, is going to start with the switch service. It's not going to start without any switch. Without any switch, this is this mode, which is not designed to run as a service. The mode that is designed to run as a service is this one, so we need to pass this service switch. Now, the easy way to do that is that you go to the service, to the registry, and you add at the end service. Let's see if that's right. Oh, it did start. So now if you go back to the task manager and have a look at the service here, and you can see that the service started. And what information here we can get? Not much, but at least we know that it is sticking around and it's running. Did the system start? That's a good question. One way to find out is to run. Basically, I know that you can make calls and see if it takes calls, but another way that you can do is that you switch to the VBVoice control panel, and you can run the VBVlog. VBVlog shows you the status of the lines, and you can see if those lines are taking calls. Yes, they are waiting for ring, and they are ready to take calls. So the service started. Does stop service works? Let's see. Yes, it does. Did it unload the process? Yes, it was unloaded. So this is the simplest way we can do that. And another thing, can we run as standalone? Yeah, let's try from here. So I'm gonna hit F10. F10 goes step by step. So let's see what happens if we go with F10. F10 comes to main. F10, F10, F10. So we are able to debug. This is a bit tricky here that when you start the system, so I'm going to put a breakpoint here and see what happens. So F10, 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 and here you go. You realize now that that thread is exiting, so this thread is going to exit, it's not going to be here anymore, but the second thread is going to take over. So F10, and that other thread exited. Now I pressed F5. And the system is starting. And it did start. You have 2 lines ready. You're able to work on on the interface, and you're able also to break. So you can pause, and you see here that thread that we talked about, that we created actually, is stuck at this message loop to dispatch the messages and send them to the form. The other thread that started with main exited. We don't need it anymore, and everything is working. You want to verify if this works here. Let's do a breakpoint here and see if F5, and let me click. These buttons are not doing anything anymore now, so I'm gonna click start, and you see that the breakpoint is working. So this is how we can debug. Let me detach the debugger, and I'm going to close it. It closed cleanly. Did the service, was the service affected? No, it was not. So that's a nice way of interacting with the services. We can add a couple of more useful things. Instead of calling this install util, it might be useful if we install ourselves. So we teach our service how to install itself. And doing this, I'm going to do it using a command line. So if I call the command line with reg, it's going to register. If I call with unreg, it's going to unregister. You can call it install, you can call it uninstall, whatever you want. Or if you want register and reg or register, so or unreg or unregister. So this is allowed in C# to have multiple cases for the same code. So the way to do this is by using an installer to install the assembly. So you need to call basically install to install your assembly, and that installer, exactly like what we did here when we called this install util, the install util, and we passed the assembly. Somehow magically this install util will go inside the easy flow assembly and figure out if there are installers that are marked to be installed. Then they will call them and will do the installation. So let's do the same. We do this by creating a assembly installer. So I'm going to call it an installer and a new assembly. Assembly installers could be found in using system configuration install. So a new assembly installer. That assembly installer needs to know the assembly and if there's any parameters. There's a way that we can refer to the service itself and we get the assembly. So because we care here about installing the service, so we get the assembly from the service itself, wherever that service is. Although we are in that assembly, but this is a kind of clean way of doing it, because you can do it even from another process, if it's from another assembly, if you're not calling it from the same assembly, if you want to have the installer separate from the service. And on that installer object, I need to tell it to use a new context. So for this purpose, I'm going to let it start a new context. Now the process to install is, if you remember the steps here, what it did, it did an install process step, and it did the commit step. So to do that, it's always good to use try catch. So if you fail one step, you can roll back. So I'm going to do here a try. Sorry. Catch. And in the try, the first step is to install. Install takes something here called saved state. It's a hash table that remembers the steps that are done and the status of these steps. So if the steps succeeded, etc. So when you decide to roll back, if one of these steps failed, the rollback function will know from this status which steps to roll back, which steps that did something to the hard disk, put a file or created a registry, or did something that we actually need to roll it back in order to get the machine back as clean as it was. We do that by providing our own hash table, calling it state. The hash table is a generic collection. I'm sorry, it's not a generic collection. So hash table, and I will pass the state to the installer. This is the first step. The second step was a commit. If you remember from the messages, commit, and we use the same hash table. So you imagine here what happens is that this hash table somehow is going to have some states that will help the rollback. And if one of these steps failed, I'm going to roll back by calling the same installer and call the function rollback and provide the state, and it will be rolled back at this moment. So those are pretty much the steps that you need to register. And in order to unregister is basically the same kind of process. That assembly installer knows how to install and how to uninstall. So I'm gonna here I'm going to add or create a new installer. That remover again is going to use a new context. While the installer normally goes through steps and you can roll back these steps, in uninstallation may not have any meaning to roll back. Basically, you're trying to remove stuff from the file system, and if you removed a couple of things and then another thing failed, that's it. You remove them. You cannot return them. So we're not going to use the transitional installation. We'll just call the remover and uninstall without any state, and that's the code. So let's see if we build. Do we succeed to build? We did. Okay, so Let's try it then as an example to, we have the service here, right? Yes, we have it. So let's try to remove it. So I'm going to do unreg. Let's see what happens when we do unreg. Disabled. So one of the things that we need to remember when we work with the services is many times when we change the service, make modification to the assembly, and try to register or unregister, we might end up with cases like this because I was developing and changing the service and then I wanted to uninstall. That's not the code is not capable of cleanly remove the service unless you reboot. I'm going to work around this one by not rebooting. I'm just going to use another name for the service and install a new service. So let's call it EasyFlow Service 1. Let's give it a different display name. And using reg, called reg, we don't have the fancy output logs that we saw in the install util. Most of the cases when you need that, you don't need those details for your customers. You only need to mention if it was successful or not. And here we go, we added the service. We go to the to check the variable, the different parameters. So we have it as a local system. We have it set as manual. Let's see the dependency. Oh yes, so there is a dependency on those two services. The only thing that we still don't have is this service at the end. So we need that path to be with the service. You want to verify this in the registry. Again, you go here and you see that the path does not have the service switch at the end. We'll do that in the service itself. So let's not make this mistake again. I'm going to unregister it first and then make the modifications and then go back. So when I unregister, let's see, it was unregistered. And from here, F5, again, it was unregistered. So I'll go back to the code. And the way to do that is, again, by the installer. So this installer class that we created, we can, so we can add code that can do that for us. There are a couple of interesting events or methods that we can override. One of them is on after install. So this is a code that is called after the installation succeeds. So when basically the installation step is done, this is called. At this point, I can add to the registry the switch to the path that I need. And this is going to be using the registry class. Registry class requires Microsoft .win32 namespace, which we added earlier. And here I'm going to refer to local machine. And what I need to do is open subkey. The subkey is, you can always learn it from here. This is the earlier service that we created. So it's local machine again, but it's system current control set services and the name of the service after that. So we'll copy this one. I have it on another, sorry. It doesn't want to. Okay, so let's do it one more time. So system current control set and services. Adding to this our service name, which is always here. And I want to, when I open this key, I actually want to allow writing because I'm going to modify it. When we work with the registry keys, it's always recommended that you use using. Using is a nice way of making sure that these components that you instantiate, they actually can be disposed properly. So using can dispose these if you forget to dispose them. So it's a good practice to when you work with such kind of objects is that you use using. So that's what I'm going to use here. For sanity, I'm going to check if we succeeded to get a key. I'm sorry. So if it didn't work or if it failed for some reason, I'm going to throw a new exception and say here failed to open the registry. And the code is going to do a simple thing. Just actually read the image path. So read image path and add to it the service at the end. So image path plus service is going to be space service nothing. So that is as simple as that. And I'm going to leave this one after, just in case there are other things that the base class would like to do after installation. Normally there is none, but just for future compatibility, if there is any changes in the framework, or if you're inheriting this not directly from the installer but from another installer which does some other things. So it's good practice always to to call the base method as well. So what this is going to do is exactly after succeeding to install. So here we can explain the steps in a better way. We succeed to install, we modify the registry, and we add what we want, the exact same thing that we did manually. Let me build this one and give it a last try. Easy flow, register. Did it register? Yes, it did. Does it have the service at the end? Yes, it does. How about the registry? Well, the answer is yes, because all these information are coming originally from the registry, so it is there. Does it work? That's what we're going to find out. Waiting for the lines to start. It did start, and the lines are ready to take calls. And does it stop? Well, we tested this before, so we know that it's going to work. To wrap this up, I'm going to give a quick review. We had a desktop application, a desktop VBVoice application already built. We modified it to run as a service by moving the code that was running for the main to another class to make it nicer. And in this class, we defined multiple switches to define different behaviors for this executable. The default behavior without any parameters is to run as it used to run as a standalone, as a desktop application. We did some modifications here that will actually let the main thread not be STA, but we create the thread that is going to be STA. We added a service, and we told the service how we want to stop and how we want to start this service. The rest is done inside the form, so starting the system and etc. if it is a timer or whatever you would like to have. And we added an installer. That installer for the service is all the code here actually could be pretty much copy pasted in your application. You only need to modify these strings, and the rest would work just like that. Actually, not just the strings, but if there is a reference to the service, you just have to change the name of the service. And that's all what you need. Needed for this one another reference, which is the service process. And to install that service, you need configuration install DLL. So also added reference to that, and the rest is just little plumbing. I hope you enjoyed this little tutorial, and please, if you need any more information, you can contact our support and send an email, and we'll be able to give you more information. Thank you for listening.